What's good, internet? My name's Emil. Today I'm going to be telling you all about my portable music production studio in a box. First of all, I'll explain a little bit about what it is. Basically, this is effectively a sampler, sequencer, synthesizer, and a mixing console all in one. So the idea is that I can have really hands-on kind of creative playtime that then turns into finished tracks at the end of the day. So from the Octatrack, I've got 8 sampler tracks and I've got 8 MIDI tracks. The sampler tracks are all sequenced in the Octatrack, and they allow me to kind of twist samples, mangle things up and process them all completely in the Octatrack, sequence them, arrange them, and do all of that stuff. The 8 MIDI tracks allow me to do that same thing, except I'm not controlling the samples in the Octatrack. Instead, I'm controlling this, which is a Virus TI Snow that has seen better or worse days, depending on how you look at it. So this does 4 independent parts running at the same time. So I can have 4 virus patches running, all independently sequenced by the Octatrack. So that's 4 of my 8 MIDI tracks in the Octatrack. And then the other 4 can control virtual instruments on this, which is a computer hidden behind this touchscreen. It's an Intel NUC, which is a small mini PC. They're intended for things like home theaters and stuff like that. But it's got pretty good specs and it runs Bitwig, which is really, really touch friendly. So I can run virtual instruments in Bitwig and I can have the Octatrack telling them what to do. So all the sequencing and arranging still happens on the Octatrack. It's also taking a stereo input from the Octatrack and a separate stereo input from the Virus. So then I have a basic kind of sub-mix for all my synth parts, a sub-mix for all my sample parts, and then I have individual channels in Bitwig for all the other virtual instruments that are being sequenced by the Octatrack in there. And with that, I can then treat Bitwig kind of like a mixing desk and use that to have individual effects chains for each of these parts. And to process everything, I can even do some master processing. I can do it all on the fly with really, really low latency. And that means that basically in this one box, I have everything I need. I have hardware sampler, hardware synthesizer, got all that hands-on feel, but then I've got all the flexibility of a DAW. I can record things on the fly. I can resample things, twist them up, and do whatever I want and have crazy sort of processing going on, all the advantages that you have with software. So the stereo output from the computer basically can be basically a finished track. It means that everything can happen in real time, and I just have to hit record, play through a tune, and then it's done and it's mixed and everything's finished. So I've been working on this for about 9 months since I started designing it, including sketching on paper and then 3D models and then vector files to send off to laser cutters and all of that stuff. So that gets quite complicated. I had to learn all about electronics and all of that stuff. I didn't really know anything about woodworking or electronics. I bought my first soldering iron to start this project. So that should give you an idea of how much of a novice I was at the beginning. And I do feel like I've learned a lot along the way. So first of all, the why. I spent a lot of time commuting in and out of central London, and I got an Electron Digitact, which is kind of like the Octatrack. It's like a stripped down version. It's more of a drum machine than it really is a fully fledged sampler, but it's a lot of fun. I had that running off a little USB battery pack, and that worked okay for a bit, but I was really missing out on synthesizers. I love synths, and I wanted to have something that would give me all of that on the go as well. So I traded up to the Octatrack and a Virus TI Snow before it looked like this, and I just had those two in a kind of cobbled together wooden hinged frame with the same battery pack that used to power the Digitact. It ran both of them perfectly well, but it was really simple. I could only get direct monitoring from the Virus through the Octatrack to the Octatrack's headphone output. So it was just, I didn't really have a whole lot of control over levels and stuff like that. It was quite tricky to work with. I had no means of really recording it unless I hooked it up to something else that had recording capabilities, and it was all just a bit of a mess. So on top of that, I also had the problem that if I got off the train and it happened to be raining, which in London is an inevitability, I would then have to just run for cover because the box was shit and it was full of holes, and it had been built by someone who didn't know what they were doing. It was me. And so I had to come up with a way to make this a bit more weatherproof so that I don't have to freak out every time I see a drop of rain. So I had to decide how to solve all of these problems. I picked up a program called Tinkercad. It's like a free web-based CAD design software. So I learned how to use that just so that I could start seeing how everything worked in 3D space, make sure that everything was going to fit together, make sure that I could fit an interface in there, because it's obviously, you know, I need an audio interface, I need MIDI interface, I need all of this stuff, and, you know, rewiring the the I/O to these front panels so that there's nothing exposed on the back. Again, that was like a big part of the kind of weatherproofing idea, was that I wouldn't have any exposed connections anywhere when the box is shut. I still didn't really know what device I was going to use to be recording things with. There were options like a Raspberry Pi, or maybe there are some other x86 machines, so that would mean I could run maybe even Windows, but more likely Linux or something like that on devices by Odroid, or maybe even like an Intel Compute Stick. These very low-powered kind of x86 machines, they usually run on Atom processors and stuff like that, so you're not going to do much heavy lifting, but it'd probably be good enough for recording. And then I stumbled across these Intel NUCs. The NUC is basically Intel's answer to people who want a really, really low form factor computer, kind of like a Mac Mini or something like that. So they run fully fledged laptop hardware, meaning that they have proper processors and proper RAM and stuff like that, but they're tiny. It's something like 10 by 10 centimeters, very, very easy to work with. It's not much larger than any of these other single board computers, and it has a whole lot more power. So I decided to go with that, and then the rest of it started taking shape around that. So once I decided that I was going to be using an Intel board and I could actually run Windows, it became obvious that I needed a proper interface. I needed some way of getting audio in and out. I spent a long time playing around with the cheap Behringer UCA 202 interfaces, which just have the kind of RCA ins and outs. Obviously, I want 2 stereo inputs here, so I would have to use 2 of them. ASIO for all would let you kind of monitor multiple devices at the same time, as long as they're class compliant. So that was one option that I was looking at. I spent a long time tearing those interfaces apart, desoldering various bits and pieces, trying to kind of fuse 2 of them together into one interface with a headphone amplifier so that I could have direct monitoring for all the inputs and all that stuff. It got really, really complicated, and I killed about 5 interfaces in the process. And then I stumbled across this ESI Maya 44 USB Plus, which, I mean, it's basically the same as the UCA 202 in that it's an RCA input-output basic low-profile audio interface, not very high-tech, still pretty bloody cheap as well, but this one had 4 analog inputs, so I could have 2 stereo inputs at the same time, which is a complete game changer, and it fits in the case perfectly. The other big question was power. How do I actually power this thing? I've been using this little USB battery pack, and I've been using it with a couple of these really cheap USB to DC voltage converter cables for ages, which just stepped up the 5 volts to 12 volts. They're really inefficient. They didn't really put out much current at all. It's a fucking miracle that they actually managed to power both of these things in the first place. And I needed to step that up. Not only because I was going to be running more devices, but because even just the Intel NUC would need a 19 volt power supply, and there was nothing out there that I could find that would be able to do that. This thing will draw like 65, 75 watts, something like that. And I settled on the prospect of building my own battery pack. It was pretty much the only way I was going to be able to guarantee that I would get the right voltages out to the right devices, and that I would be able to make sure that they could draw all the power that they needed to draw, and it wouldn't be a problem. So I spent a bunch of time watching YouTube videos and reading about just basic electronics that I didn't know anything about. So I basically set about putting all of these ideas together. I've got the power sorted, I've got the signal sorted. I know that I found this touch screen that would work with the computer that had like an HDMI input, and I wasn't sure how much power it was going to draw, but I figured if I just put enough battery cells in there, then I'll probably be all right. And sure enough, it all ended up kind of coming together in the end. So, first of all, before I get into all the inner workings and the electronics and all of that, I think I should probably just talk about the way the actual case is put together. So I can take these cables out for now. Basically, this is just a solid plywood box. I used box joints all around the edge. It's just wood glued together. I painted it with a load of black wood dye, and then I just sprayed it with a bunch of satin polyurethane varnish, which is supposed to be pretty good at kind of expanding and contracting with different temperatures and moisture and all of that stuff. And it's supposed to last a really long time. I figured that'd be good. It's scratching all over the place. I think I did a really crap job of applying it. I don't really care as long as it's functional. It seems functional so far. So I might give it a once over at some point. I also drew this little octopus dude on it, and I gave it its name, Covert 19. I finished it in lockdown, and it has a virus in it, so it seemed like an appropriate name. But yeah, basically, this is just a plywood case based on the designs from Tinkercad, I created an Illustrator file which had all the flat shapes for all of these different panels inside it. And then I sent that off to a laser cutting place called Swordfish Works based in London. It was very reasonable, but I think it cost me like £100 or something, maybe less, to get it all laser cut in 9mm plywood. So they gave that back to me and I basically just stuck it all together and it worked. Aside from that, the hinges, I think they're cheap off eBay. They're just plastic. I mean, like, look, I've been buying all these shitty eBay components. These screw heads are rusting already. These latches and stuff, these are Penelcom latches and Penelcom handle. These are like flight case fittings that, you know, if you want to repair your flight case, they sell the individual bits. So I bought a load of those and they seem to do the job. They seem to fit. I got these gas struts. So these are basically just, you know, cheap as shit. They're like £6 or something for a pair of them. 40 Newton gas struts. They basically mean that while I'm outside using this, no one can knock the lid shut on me. And also, yeah, I mean, well, they just keep it up and in the right position and all of that stuff as well. I also went for this expanded neoprene gasket. So it's like a kind of rubber foam with a smooth outside that is really kind of spongy and very water resistant. It also is resistant to like oil, high temperatures and all this stuff. It's supposed to be very, very good for kind of sealing things, basically. So the idea is that I have a higher thickness of this neoprene gasket than I have space between the lid and the bottom of the case, so that when I close the case, it compresses it by about 50%. So that means that it's always under pressure, which holds all the water out. So I have this one around here, and there's a solid non-foamy version around the top edge, and then at the back I have this battery access panel, which you can see here. So I've got these 6 screws which I can undo, and then behind them is all the electronics, the batteries and stuff like that. So I also have neoprene gasket around here as well, just to keep all of that stuff safe too from the elements. It looked a bit messy when I did it, and I thought that maybe a really good idea would be to spread some black silicone sealant around the edges with my finger, because obviously that would make it look super professional. So I did that, and you know, that stuff's all like peeling off, like it's all just shit. So I'm probably going to redo all the seals at some point. But they're functional, they do work, so it's not a high priority for me, and I'm kind of okay with it looking like shit. It kind of adds to the character. I'm more concerned with whether it works well, and thankfully it does. So what I'm going to do now is I'll talk you through the power. I'm going to pull off this back panel quickly, and then we can have a look inside and I'll show you what's going on. Right, so here we are. I've pulled the back panel off and now you can see what's going on inside. So this big lump here that looks not at all like a bomb is the battery pack. This has 12 lithium-ion 18650 cells in it, so these are like vape batteries basically. They're in a 4S3P arrangement, which means there's 4 batteries in serial, 3 in parallel. That means that it will do between 14 and 16.8 volts, which is good. It means that really the lowest voltage these batteries should ever go to is 3. So it should never go below 12 volts in total, which means that at its lowest power, it will never need boosting to be able to power the Virus or the Octatrack, because both of those run on 12 volts. Aside from that, we have back here, there's 2 of these switching boost buck converters, so like voltage regulators basically, and then there's 3 more at the front here. So this one here is for the NUC, so this basically boosts the voltage, whatever voltage is coming from this battery pack, to 19 volts so that it can power the computer. There's a little protection diode in there as well. This one does the same thing, except it drops it down to 5 volts, which powers this little Midi through box, which I'll talk about in a minute. And then there are 3 more here, and these are all doing 12 volts. One of them is for the Octatrack, one of them is for the Virus, and then I have 1 spare. You can see I kind of terminated this cable here, so it's not actually used for anything now. I was thinking that initially I was going to build a headphone amp into it or something like that, which would need a 12 volt power supply. I decided against that in the end, but it's nice to have. It means if I do want to expand this in future, I can use that. So this MIDI through takes the MIDI output from the Octatrack. It sends it to the Virus, it sends it to the computer, and it sends it to this front panel port that I added inside the box so that I can connect a MIDI cable through the front of the box and use that to sequence external gear from the Octatrack. So if I have an extra synth I want to plug in or something, I can just run that straight from this MIDI port, and then I've got actually the left and right, or A and B, Octatrack inputs here as quarter-inch jack inputs. So I can then run that synth back through the Octatrack and into my computer through the interface, so I can kind of integrate additional pieces of gear as well. So that's one thing that is really nice. As you can see, I've got this big mess of crimp connectors here. This is for all the power switches. I wanted to make sure that I could swap out this battery pack in future, or just kind of basically be able to disconnect all of these power connections for maintenance reasons later down the line. I hate these crimp connectors. They're a bit dodgy. I've soldered them all in so that they're extra secure, but I still might swap them out at some point for Molex connections instead, because I do think that they're a little bit more reliable. But these will do the job. They will work. So you can see I've also got all of these audio cables in the back of the Octatrack here. I've got like the headphone output, which is connected to this stereo mini jack socket in this front panel. I also have all my power switches here, and I have the main stereo out from the Octatrack coming out here, and it goes along these cables which go up into the top of the case, which we can take a look at now. Right, so here we are back up top, and I'm going to unscrew this front panel here to show you what's inside. So basically, I have these 4 screws here, there, and there. They are the things that hold on this whole entire front panel. So I'm just going to pull them out now and we can open it up. Now this is where it gets tricky, because to save space with all the cabling in here, I've had to keep these cables really short. So there are a couple of things that I need to unplug as I'm pulling it out so that the case can actually come down. And there we are, we're in. You'll probably notice where these mounting points are for the screws. I've got these little threaded inserts which allow me to use machine screws, so I can kind of unscrew this and screw it back in as many times as I want without ruining the threads in the wood. For example, if I was using wood screws, this would not be a good idea at all. And inside we have my audio interface. I've got a USB hub. I've got my MIDI interface. This is a little mini DVI to HDMI adapter, which I'm using this tiny ribbon HDMI cable in, which is used for drones and things like that to connect to this HDMI port on the front panel here. The USB hub has the MIDI interface connected to it. It has this little wireless dongle thing for this little keyboard, which I can use. So if the touchscreen is a bit too fiddly for some things, then I have this like touchpad, mouse and keyboard combo thing that I can use with it, which is really handy. And then these 2 ports actually go out the front here, so I can connect USB sticks or anything else that I want, any external devices that I want to connect to it. This is a power button for the computer. It doesn't actually work at the moment. I think the connections have come loose inside, but also I don't actually really need it, so I'm not that bothered right now, but I'll probably fix that at some point. Down here, these are the PCBs for the virus. They are still mounted to the virus's original front panel, which I had to very, very gently remove. This is the Intel NUC, which is the tiny little PC, and I've got this kind of little mounting assembly here. So there's a piece of wood between the computer and the touchscreen with some standoffs just so that everything fits. And actually this thing's so thin, it has all of these, you know, I/O ports on it, and it's got a little heatsink here and a fan, and there's still actually about maybe 0.5 centimetre to 1 centimetre of clearance between this and the back of the case, so there's still room for it to suck air in through the bottom. And then I've got this venting here at the top, so it can blow all the hot air out the top. And it seems to be working really, really well so far. I'm not really getting very high temperatures at all. I think most of the time under full load it ends up about 60, 70 degrees, so I've never seen it break 70, which is really nice. And then you can see here, these are the Wi-Fi antennas. There's one here, which I've just kind of hot glued onto the thing there. There's another one here, which typically, having been hot glued, has now come unstuck as I've opened it up. So that's going to be really fun to try and put back on before the end of this video. But yeah, that's pretty much it. So basically, I've got this MIDI interface, which takes the MIDI from the Octatrack and sends it straight into the computer. The Octatrack MIDI comes up here as well and goes into the virus through this little cable here. Then I've got MIDI out from the computer, which goes back into the Octatrack, so I can control the Octatrack from the computer, which I'm not really using much at the moment, but I do have some ideas for how I'm going to use that in future. I have USB connections for the Octatrack and the virus to go to the computer, so I can save patches, back up, my sound banks and stuff like that. Here I have my main output. It's just these phono connections. They come down here and they're soldered to these left and right jacks so that I can send audio straight out from the interface. These are the inputs up here. There's a little headphone output there as well, which I've basically split into two. They're a bit noisy at the moment, so I'm going to need to redo the cabling on that, but other than that, it's all good. I think there is a little bit of hum in the background of this, so there's a bit of a noise floor. Actually, it's a hell of a noise floor, actually. It's still usable, and it's perfectly fine for kind of day-to-day mucking around, but I'm going to have to put some shielding between the interface up here and the virus here, and a bit between the computer as well, and maybe some to protect all of these ins and outs at the front there as well. Once I've done that, I'm pretty confident that it will be really nice and quiet, but it's still usable for the moment anyway, so that's something to do later. So I'm going to put all this back together now, and I'll see you back up top. Right, so here we are, all put back together, and now I can actually turn it on. So this is my main power switch, but all these are still off, so I turn these on one at a time usually, just because otherwise they'll create too much load on the battery pack to turn them on all at once. That's it. Octatrack, virus, computer, and it's alive. Okay, so here we are. Everything's on, it's all running, and I can show you a little bit of kind of what happened. So I'm on the mix view here on Bitwig. You can see there's a little bit of signal there coming in on the Octatrack and virus channels. That is the noise floor that I was talking about. But, I have all this stuff running really low latency, and it all sounds good enough to work with. So this is a track I've been working on recently. It's like a little drum and bass thing. It's just a bit of fun, really. It was a good opportunity for me to try a bunch of stuff out and see what I could do. Basically, what you can see happening here is, this is the mix view on the Octatrack. So these are all my sampler tracks. These are all my MIDI tracks. And I have all the synths and the bass and everything you hear is coming from the virus. A lot of the percussion, other bits and samples and bits and pieces are all coming from the Octatrack. But you'll notice I do actually also have in my mix view here two other tracks. There's one here for the kick and one for the snare. So basically those are running in a drum rack in Bitwig. So this drum rack here, you can see it has this kick and snare sample loaded in, and I have processing chains on those. So I can, for example, what I'm doing in this project here, which was something I was really looking forward to doing when I got this all set up, was that I'm taking the full stereo input from the virus, I'm band splitting it. So if I open up my virus channel, I go to my effects chain here, got a couple of filters and stuff like that. So here I've got this low, mid, high, which is basically a separate individual effects chain for each of these bands. And what I'm doing is I'm sidechaining the kick to the low end of that band, so that includes my sub bass, for example, and I'm sidechaining the snare to this mid band, which kind of lines up with the snare's fundamental frequency range, so it's something like 170 to 300 or something like that. But that basically means that I can do these kind of little intricate mixing bits and pieces that I just never could do before when it was just the Octatrack and the virus. I can have these, like, these little side chains, bits of compression here and there, bits of EQ here and there, that just make all the difference in getting things sounding really nice and tight. I also have effects chain running on the master, which has a compressor and a limiter and all of that stuff as well. Obviously, the limiter is not able to do any look ahead with zero latency, so it's just doing a bit of soft clipping and stuff at the moment. But really, I can't be bothered to engage in all the super mixed down and hyper engineered loudness war things anymore anyway. So actually, as long as I can get it nice and loud and clear, that's perfectly good for me. So I'm really looking forward to getting stuck into this more, figuring out all the different things that I can do with it, getting the mixes that are coming out of it sounding better and tighter, and you know, just I think there's going to be a lot of scope for me to play around with it. So cheers for watching. I'm going to be uploading shitloads more videos of this box, just, you know, performing tracks or anything I figure out how to do with Bitwig. There's some bits and pieces I've been working on, like I have a controller script on here which kind of augments the functionality of the Octatrack scenes into Bitwig, so I can use this crossfader to modulate pretty much any parameter in the whole of Bitwig, which I know is something that a lot of Octatrack users might find interesting. I'm also working on another project which will allow you to kind of bounce stems for individual sampler tracks from your Octatrack, which is something that in lieu of Overbridge is going to be quite handy for a lot of Octatrack users as well. So yeah, I'm going to be posting up more videos of bits and pieces. If you're interested, then stick around. Nice one. Laters.